The next topic will be discussing about the pressure control valves. With the help of these valves, we will be controlling the pressure in the hydraulic systems. Now, I may be limiting the maximum pressure, I may be limiting the minimum pressure with the help of these pressure control valves. Various pressure control valves we are having. The first one we will discuss about the pressure relief valve, which is the important component or the important valve in case of all the hydraulic systems. Right? Whenever we will be going for using the positive displacement pumps, then compulsorily we should go for using such type of pressure relief valves. By the use of this pressure relief valves, the system can be safeguarded. So this is compulsory whenever we will be going for the positive displacement type of pump. It consists of the puppet which will be seated in the seater, and the puppet will be backed with the help of the spring force whose stiffness we can control with the help of this adjustable knob, the adjustable screws. It consists of only two ports, one is the inlet port and one is the tank port, right? And this is the graphical symbol of a pressure relief valve where I will be getting the signal, where the signal or the call it signal will be taking from the inlet side itself, right? So this is nothing but the line, this is the pump connection. Here I will be connecting one line to this pressure relief valve. Whenever there is an excess pressure that has been built up in a hydraulic system line, in that particular case, automatically the puppet will come out of the seater because of the increase in the pressure compared to the spring force. Then obviously I will be having the space to move the hydraulic fluid from the inlet to the tank port again. Right? Even though there will not be any work which will be done with the help of pressurized fluid, but I can safeguard our hydraulic system with the help of this pressure relief valve. The pressure relief valve, whatever we have indicated, that is a puppet type of pressure relief valve. Right? So in the animation we can see here, whenever there is a built up of pressure here, then obviously the puppet will move in the upward direction so that the pump flow will be connected to the tank port. The same thing will be representing in the symbol also. See here the arrow mark, whatever I am having here, that will be moving from off center position to center position. Along with that one, the spring is going to be compressed stage, right? So in order to compress the spring, first what I should have? I should have the enough pressure here, which should be more than this spring force. Then only it will move from off center to center position. Right? So this is nothing but the correct location where we will be connecting the pressure relief valve to the hydraulic system. Right? So the line, before connecting the line to any application, the pressure relief valve will be connected. There are two types of pressure relief valve. One is the direct operated or inertial type, and another one is the compound of the wallet operated design. This is nothing but the direct operated, whatever we have discussed now. Let us see how the compound relief valve will work. This is the symbolical representation of the compound relief valve, and this is the pictorial representation, right? So I will be connect. This is the pump from where we will be taking the fluid, which will be connected to the system, and in between I will be having a one line which will be connected to this compound pressure relief valve. So we will be controlling the pressure of the fluid in two stages here. The first stage is here with the help of the coiled puppet, and the second is here with the help of the bias piston. Okay. So this bias piston is consisting of the orifice here. So with the help of this orifice, the fluid can move from the lower end of the piston to the upper end of the piston, right? So let us see how it will work. Initially, the fluid, whatever that is coming from the pump, I'll be having the obstruction here because the stem which is connected here, that is completely closing to move the hydraulic fluid from this port to this port, right? I will be having the obstruction here because of this stem, right? So there will be equilibrium that has been achieved, that is the amount of fluid which is acting from the bottom side will be same as that of the pressure which is acting from the top side, right? So obviously the fluid will be moving from this line along with this pilot line, and that is going to be acted on this smaller puppet, right? Once it reaches a sufficient amount of pressure here, right? Once it reaches a sufficient amount of pressure here, which will be more than this pilot spring pressure, then obviously the puppet will move against the spring force. That is, the puppet will come out of the seater, and I will be having the space in order to move the hydraulic fluid from this pilot line to the tank. This is called as the bypass line, right? From the bypass line, the fluid will be moving to the tank, right? So again, if you continue the same process, then again if there is a still increase in the pressure, then obviously the whatever the lower end we are having, lower end of the piston we are having, which is having more pressure compared to the spring force which is acting from the top side. In that case, what will happen? In that case, the piston whatever we are having here, that will be moved in the upward direction. Along with this one, the stem is also going to be moved, right? So if the stem is also going to be moved, then obviously we will be having enough space in order to move the hydraulic fluid from this port itself, right? So instead of moving in this direction, right, obviously when the piston is moving in the upward direction, obviously I will get the space here, enough space in order to move in this manner itself, right? So this is how the piston can control the pressure of the fluid in two stages, right? The first stage is here and the next stage that will be here, right? So next one is unloading valve. This unloading valve is used mainly at a minimum load condition, right? So which will be operated for the minimum load condition. That means at a regular interval of time. Normally it is in a closed condition. Normally the valve will be in a closed condition. Whenever we are applying the sufficient amount of a pilot signal, then only there will be a movement of hydraulic fluid from pump port to tank port, right? So this is nothing but that has been represented in the symbol here also, right? So this is in the off center position. There will not be a connection from one end to another end. Once I apply the pilot signal here, then only it will move to center position, so that I will be having the connection from this end to this end, right? So similarly here in the pictorial representation, initially the spool land whatever we are having, that is going to block the tank port, so that the pump port is blocking the hydraulic fluid here itself, right? Once you apply the pilot signal here, which will be acting at the bottom of this puppet, so that the whole piston will be moving in the upward direction. Once it moves in the upward direction, then obviously I'll be having enough space to move the hydraulic fluid from pump port to the tank port, that is from this end, right? So this is about the unloading valve. Next one, the sequence valve. The function of this sequence valve is to carry out the sequence of operations, right? So this is the symbolical representation of the sequence valve. Initially what is happening, the inlet will be connected to the primary output, that is from here to here. But whenever there is an increase in the pressure in this line, the increase in the pressure is going to move along this solid line, which will be acting at the bottom of this piston, so that the piston will be moved in the upward direction. When it moves in the upward direction, obviously this port, primary port will be closed with the help of this bottom piston, and similarly this will be moving against the spring force, so that I will be having the connection from inlet to secondary port, right? So unless until I get sufficient amount of pressure here, the secondary port will not be in a open condition, right? So that is in the case of sequence valve. Let us see the one application of this sequence valve. The first one is for the clamping cylinder, that is in order to clamp the workpiece, right? So this is nothing but the workpiece I am having. So this is the workpiece and this is the stationary element, right? First, what is my intention? I need to clamp the workpiece. After that only I need to make a drill, right? The drill bit, assume the drill bit is connected to this piston, right? So now I will be actuating the first position by supplying the electrical voltage to this solenoid, and my pump port will be connected to system port A. That means the flow will be getting to the blind end side of the cylinder, right? Along with that one, the fluid flow will also move in this direction. Here it will be blocked because of the check valve. Here it will be acting, but because of the lower pressure this valve will not open, right? So now only option is the hydraulic fluid has to apply the force or pressure on this piston unless until the workpiece is rigidly held here, right? So the piston will be moved in the forward direction unless until that will be rigidly held here, right? Once the workpiece is rigidly held, then there will be a back pressure which is generated, which is it will go on increasing unless until it is going to open this signal, right? This is nothing but the Paulet signal, right? So this pressure should be more compared to the spring force whatever we are having here. In that case what will happen, it will move from off center position to center position, so that I will be getting the flow to the blind end side of the extended cylinder, right? In that case again it will start moving in the forward direction, so I will be getting the drilling, right? Once the workpiece is going to be drilled, then obviously that has to be, the drill bit has to be taken out from the workpiece, right? For that one we need to actuate the another position, right? So let us see what will happen in the second position. When you actuate the second position here, a pump port will be connected to system port A. That means the fluid will be moving in this direction, this direction, this direction, as well as the fluid will be moving in this direction, right? The fluid whatever we are having, that is going to be acted on the rod end side, so that I will be getting the retraction motion of this extended cylinder, and the fluid on the blind end side will be moving till here. Because of the obstruction I won't get the flow here, and the bypass line is a check valve line. From this check valve line it will move, and it will move in this direction, and it will again send back to the this port, system port A, and that will be circulated to the tank, right? So once it completely retracts, that means once the drill bit is going to be taken out from the workpiece, then obviously this clamping is also going to be, clamping cylinder is also going to be retracted. That means the declamping has to be done, right? So once it reaches a complete retraction, then the amount of fluid is also going to be circulated here, and the clamping cylinder is also going to be retracted, and the fluid whatever we are having on the blinded side, that will be added to this port A, that means enter to the tank port, right? So in order to carry out the various sequence of operations, that is first clamping of the workpiece, again the drilling of the workpiece, again removal of the drill bit from the workpiece, again declamping the workpiece, right? All these operations has to be done in the sequential manner, right? So in that case we'll be using the sequence type of valve, right? So the next one is the counterbalance valve. This is the graphical symbol of the representation of this counterbalance valve. The counterbalance valve is used in order to maintain the free falling of the vertical load, right? So we can discuss here with the help of this diagram, right? So first what I will do, I will go for actuating the first position. I will go for actuating the first position. ಈ position actuate ಮಾಡಿದ್ಮೇಲೆ ಏನಾಗ್ತದೆ, the fluid will be taking place from P to A, right? That means the pump flow will be circulating here. I'll be getting the fluid on the blinded side, so the piston will be moved towards lower side, right? The fluid whatever we are having here, this one I'll be restricting because of this counterbalance valve, right? Because this check valve will not allow the fluid to flow because of this spring force only. This can be the moment of the downward movement of the vertical cylinder can be controlled, right? So this is nothing but it is not necessary to switch on this pump continuously, right? Whenever you need the downward movement, then only you actuate the first position. In that case the pressure limit whatever we have set, that is if it is set for 10 bars, then obviously I will be supplying the 12 or 11 or 12 bars, then obviously it will move the downward direction, right? So whenever we want to move in the load in the upward direction, then obviously you go for switching on the second position, so that the fluid will be moving in this direction. Here it will be obstructed, and here with the help of this bypass line the fluid flow can be taken place, right? So that I will be getting the upward movement. But due to this heavy load which is happening because of the gravity, it is not necessary to switch on this pump continuously, right? In that case what we'll be using this counterbalance valve, right? That is the application. Next one is the pressure reducing valve, right? So in the previous cases we have reduced the inlet pressure, but here we are going to control the outlet, we are going to limit the outlet pressure, right? So this pressure reducing valve will be always in a open condition. That means there will be always the flow from pump port to the outlet port of the controlled pressure port. Whenever this pressure is going to be reached beyond a certain limit, whenever whenever the outlet pressure is going to be reached beyond the limit, in that case the signal will be connected from this signal line. That means the hydraulic pressure will be acting from this signal line, and the piston will be moved in the upward direction, right? Whenever it will be moving in the upward direction, then obviously it is going to block the controlled pressure line, right? That is how we are going to control the outlet pressure. As well as if there is not enough pressure, then obviously it is going to restrict the amount of flow rate. Only a small space is available, right? So whenever you get a controlled pressure, in that case again it is going to move in the downward direction, right? So the symbol whatever we have shown here, the dotted line, that is connected to the upstream, not to the downstream, right? And the drain line is there whenever, because of some clearance, there is a small amount of hydraulic fluid, sometimes that may flow to the spring side also, that can be removed with the help of this drain line, and the stiffness of this valve can be controlled with the help of this adjusting knob or the screws, right? So this is in the case of the pressure reducing valve, with the help of which we are going to limit the outlet pressure, right? Thank you for watching.